Good day, everyone. We meet again. Obviously, as we begin to continue to, or rather, as we continue to do our study on physical science, in particular chemistry. Well, today we'll be starting with organic chemistry. Oh, I'm excited to start with this one. I've received so many queries, sorry about it, and so many people have been asking and inquiring when am I starting with organic chemistry. So my approach is going to be a little bit different today. I want to make sure that I know most of you have access to other material and stuff like that. Whilst mine is going to be an approach that tries to cover everything on organic chemistry, but I'm not going to be so so meticulous when it comes to the theoretical part of it, because I know that many people were inquiring because they were struggling about the naming part, how to name organic compounds. So I want to start with that. I want to introduce it and phase it in. Okay, so if you haven't subscribed, ladies and gents, please make sure do the right thing. Okay, so and please, you can reach out on my email, reach me on my email, and my email address is mlungisi.m.nkosi@gmail.com. All right, and please just throw a comment and do the right thing. Okay, right, let's get into it. Organic chemistry. So essentially, what we have is that the central element that we have in organic chemistry is the element carbon. It's very special. Okay, it falls under a group of semiconductors, but also it's got one of the highest electronegativities. So in this case, in this regard, it shares a very special vertical and a horizontal relationship. Now, obviously, carbon has got an ability in this case to form long chains, and as a result, because we can form up to millions and millions of chains, we call those groups aliphatic compounds, the ability of carbon to form long chains. But it can also, again, make what we call aromatic compounds. Those are ring-like structures. So now I'm going to be focusing today on aliphatic compounds, okay? That is the ability of carbon to form long chains and how to go about naming that. I want you to think about organic chemistry as a language, okay? I know it's kind of strange to say that. Now remember, every language has got its rules, right? And I'm going to teach you the rules first, and I'm going to phase those rules in. And by the time that we're done, you're going to be able, I promise you should be able to name just about any organic compound, okay? Just please follow me in the rules. Right, so if you think about English, we've got something that we call a prefix, right? If you think about any prefix, something like re, right? Replay. So when you use the prefix re, it tells you something, but a prefix is not a word in itself, right? So in this case, in organic chemistry, we've got a prefix as well, okay? Right, and what do we base our prefixes on? We base our prefixes on the number of carbon atoms that are there on the compound. So, for instance, if I've got one carbon atom, okay, so you must just keep in mind that carbon has got 4 bonds or 4 valent electrons, so it's able to make 4 bonds around it. So the prefix there should be the prefix meth, okay? So that's our prefix, right? If I've got 2 carbons, all right, in my compound, so the prefix that I use, in fact, let me just create some space there so that you can see that clearly. So the prefix that we use is the prefix eth, okay? All right, or in some cases you can say ethen, all right? And 3 carbons, we use the prefix prop or prop, Okay, and if I've got 4 carbons, I'll use the prefix. Okay, please don't mind if I don't put in all the bonds. We use the prefix but or butane, right? In this case, if we've got 5 and we're going to limit it to 8, okay, so if I've got 5, okay, then I use the prefix pent, okay, or penten, right? And if we've got 6, we use the prefix hex. Okay, so if we've got 6 carbons, then we use the prefix hex. All right. If we've got 7, we're going to use the prefix. So that's 5, 6. Okay, I'm going to put the 7th one there. Okay. All right. So if we've got 7, then we use the prefix hept. Okay. So note if when I use the prefix, can you see I've got a dash there because I'm simply saying the word is not complete yet. Okay. And then the last one that I'm going to do, or because we limit it to 8, but of course you can continue. Okay. 4, 5, 6, 7, 8. I'm gonna squeeze that one in there. Right. Of course, you should always try to. Okay. So in this case, when we've got 8 carbons, so then we say that the prefix is oct. Okay. Right, so these are prefixes when it comes to organic chemistry. By the way, if you wanted to continue, if you've got 9, you use non, and then with 10, you've got dec, right? If you think about it, it sounds like, you know, when it starts from 7, it does sound like some months in the year, right? September, October, November, non, December, dec, right? So in this case, there's a reason, by the way, that coincides. Okay, but I won't go too much into that. Right. So in this case, what we're simply saying is that when you're going to name in organic chemistry, you must first of all know, okay, these prefixes. Now, there's no way that I can learn this for you. You have to know it for yourself, right? So, you know, when I've got 1 carbon, it's the prefix meth, okay, eth for 2, prop for 3, but for 4, pent for 5, hex for 6, hept for 7, 8 for oct, right? So in this case, when you know your prefixes, then in this case, what it does is that it helps you in the naming, right? Now, then we've got a group of hydrocarbons. Now, what I'm going to simply do, we said we've got aliphatic compounds. Okay, so in our group of aliphatic compounds, those are hydrocarbons. We've got hydrocarbons that we have. Now, we're going to expand this as we go along, but please just stay with me for now. Okay, actually, I should have just created a bit more space there. All right, so in our aliphatic compounds, we've got the first group, okay? Right, and in this case, we've got what we call a homologous series, right? Okay, and those are a group of compounds, right, that have the same general formula, and in the series, they differ from one another by CH2, right? So in this case, suppose we've got something that has single bonds between carbon to carbon, right? Between adjacent carbon atoms. So in this case, then we use a suffix, okay? So when we've got single bonds only between carbon to carbons, okay? Of course, we're talking about just hydrogen and carbons, right? So therefore, we use the suffix. Now look at this. We use the suffix "-ane", all right? So we use the suffix "-ane" in this case, right? And then if we've got at least one double bond between carbon to carbon, okay, right? So we will use the prefix, or rather the suffix. Now remember, suffix comes at the end of a word, right? So we use the suffix in, okay? And if we've got triple bonds between adjacent carbon atoms, right, at least one triple bond, then we use the suffix ein. Now if you just notice how logical this thing is, right, it's kind of like what you did in primary school, AEI, right? The only reason why that was changed for a Y is because an I, like the letter I, started coinciding with the number 1. Okay, so in this case they changed it so that so as to eliminate the confusion. Now these expressions are made by what we call the IUPAC, right, which is the International Union of Pure and Applied Chemistry, right? So this is an international body, all right, obviously, so that they come up with international standards and norms for pure and applied chemistry. Right, now what we want to do is, I don't want to bore you much. I'm going to start with our aliphatic compounds. We're going to start with the hydrocarbons first, right? And what I want us to do is just to name. Now keep this in mind, right? Keep what I've written here in mind. Keep what we have there in mind. So for instance, if I've got, okay, so now, as I said, I didn't take you through too much of the theory. We'll get to other aspects. We'll do reactions, right? So suppose I've got something like this, okay, right? I know you should be able to name that with ease, right? So in this case, what do I notice? I've got 3 carbons. So if I've got 3 carbons, right, I know in this case I'm going to use my prefix prop, right? And if I use the prefix prop, right, then I look at the number of bonds between adjacent carbon atoms. Please note, I'm not looking at anything else, just between my carbons. And by the way, we need to check that it is actually just hydrocarbons for now. It's just hydrogen and carbon atoms that are present, right? And we'll get to the others a little bit later. Right, so in this case, what do we have? So we've got 3 carbons. We know prefix is prop, and it's only single bonds between adjacent carbon atoms, so it's going to be a suffix in. So therefore, when we name this, we say this is propane. So prefix prop, right, and then suffix ane, so that becomes propane. Okay, right. Take another good, cool example. Okay, so if we've got something like that, please, you must also make sure that the number of carbons, or rather the number of bonds around carbon, is always going to be 4, right? So that's 1, 2, 3, 4 for this carbon, and then for this one, 1, 2, 3, 4. So that is perfect, right? So prefix, that's eth. And we do have a double bond, isn't it? So that's going to be eth. And what's our suffix? We've got at least one double bond in this case. So this is going to be ethene. Okay, right. So I know you've got the hang of that, right? If I had, say, for argument's sake, right, I'm just going to just go on to another page. Okay, just keep this in mind. Right, I'll just keep that there. Okay, so if I've got something else, let's say we take something to that effect. Okay, we've got our carbon atoms there. Okay, we've got our hydrogens. Okay, so please, at a point, I'm going to not write the hydrogens. You're not allowed to do that. Okay, I'll just do it for the sake of saving time. All right, but please remember that you should always, when they ask you to write down the structural formula of a compound, this is what the structure looks like. Okay, The IUPAC name, how do we name this guy? We're going to say, all right, you've got 4 carbons in this case, and if you've got 4 carbons, so our prefix is going to be but, okay? And we've got only single bonds between adjacent carbon atoms, so this is going to be butane, okay? Right, now, I know some of you are thinking, okay, yeah, we get the gist of that, okay? Now, the problem comes when we now have some carbon atoms, or what we call isomers, right? So what are isomers essentially? Those are organic compounds with the same molecular formula, all right, but structurally they look different, okay? And so they've got different structural formulae, right? So more than one structural formula. So let's take something as simple as this. Okay, so we noted here, this is butane, isn't it? Okay, so this was butane. But now, what if I draw something that looks slightly different from it? Okay, now, how many carbons does it have? It has 4 carbons, right? And in this case, if I've got 4 carbons, then I know in this case I use but, okay? But now look at this. If I were to write this in molecular formula, it's C4, right? Okay, and how many hydrogens? Going to be 10 hydrogens. So this is going to be C4H10. This is the molecular formula of it. Now, if I were to write it in what we call condensed structural formula, look at this, it's going to be CH3, so it's C with the hydrogens around it, there's 3, right? Then CH2, that's CH2, and the last one CH3. So this is how I would write this down in condensed formula, right? Sometimes they don't show those bonds there, they just write it as CH3 CH2 without the actual bonds, right? Now if you take a look at something like this, okay, so as I did say, I'm going to stop writing these hydrogens down, okay, so that we save time. Now if you look at this, by the way, once again, how many carbons do we have? Right, we've got 4 carbons, 1, 2, 3, and 4, right? And hydrogens, we still are going to have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would still be C4H10. So their molecular formula, do you agree with me? It looks the same, right? Okay, we're going to talk about what type of isomer it is, but for now I want us to focus on the naming. Right, so it is, they look the same from a molecular perspective, right? Molecular formula perspective, right? So C4H10, but now structurally, if I look at that and I look at that, they look different, isn't it? So they are isomers of each other. Now the question is, how do I name this guy? Okay, right, now ladies and gents, please, I want you to stay with me for now, né? Right, so what we do is we are going to introduce what we call a numbering system, okay? Now, how do you number in this case? You always number from your side, from the side which is closest to your functional group, okay? Right, so if in case where you've got double bonds, you always number from the side that is closest to your double bonds, right? Or triple bonds, or any other functional group for that matter. And then secondly, you number so that it gives you the lowest combination of numbers, okay? So if I look at this, first, what do I need to do? I need to identify the longest chain first, right? So which one is my longest chain? So this one is my longest chain, it's 3, right? Sometimes they refer to it as the parent chain, right? So my parent chain is 3. And I want you to note this. Now I need to introduce numbers to my parent chain. So that's going to be 1, 2, and 3, right? I numbered from left to right. It didn't matter even if I numbered right to left in this case, okay? Because it's the central carbon atom that has something special to it. Now, how do I name this guy? I will start in this case with my side chain. You always start with the side chain. Look at this. Now, or what we call by the way, a branch. So sometimes they call it a branch, or you can call it a side chain. Right, so look at this. So in this case, at carbon number 2, I've got something that's sitting there, and that's a carbon atom, isn't it? Right. So we call this alkyl groups. Okay. Right. Now look at this. At carbon number 2, I've got an alkyl group, but how many carbons are on that alkyl group? It's only one carbon, isn't it? Right. So you start naming the alkyl group first. So you always name the parent chain last. It's almost like a surname. Okay. So how am I going to name this guy? I'm going to simply say, okay, at carbon number 2, right, I'm giving an address. I've got a side chain with one carbon. So I'm going to say this is 2, all right? So it's showing me the address where this is taking place. I've got a methyl, and why am I saying meth? Remember, meth means one carbon. So there's one carbon there, and an alkyl with one carbon. So this is 2-meth. Now I want you to note, remember, meth is a prefix, right? Okay, so in this case, to finish off the name or the word without necessarily finishing off the name, we use the suffix YL. So this becomes 2-methyl. It's an alkyl group. All right. Once you put the suffix "-ane" or "-ine" or "-ine", you simply mean that you are done naming. So this is going to be 2-methyl, right? At carbon number 2, we've got a methyl, and then the suffix of it, or rather the last part, right? In this case, I've got 2-methyl. How many carbons do I have in my parent chain? I've got 3. So this becomes prop, okay? And then I've got single bonds between each carbon atom. So this is going to be 2-methyl propane. Can you see that? Now, please, I want you to note, ladies and gents, between every number and a letter, okay, of the alphabet, right, we always put a hyphen, a dash, okay? Always put a hyphen there, all right, so that we are able to see the difference between the two, okay? So this is 2-methyl propane, whereas that one was butane. And I want you to please sensitize you again to the same thing, that molecular formula was the same, structurally they looked different, okay? And as a result, that is why even their naming is different. That we call butane, and that we call 2-methyl propane. Now, what I want to do quickly is to just show you how would this be like when we name it, or rather when we write it in condensed formula. So you would have CH3, you'd have CH3, and then you'd have CH3 there. Okay, so this is what it would look like in condensed formula, right? So this is 2-methyl propane. Now let's take something else. Okay, now let's talk about, suppose I've got, right, right, so here I've got 2. In fact, let's put something else there so that we don't keep using the same thing. So right, so if we didn't know what we knew, right, so what are we going to name this? Okay, please remember I said I'm not going to put the hydrogens there, but remember when they ask you to draw this, please put those hydrogens, otherwise this does not make sense, right? So just assume everywhere where there's those bonds that there's a hydrogen. Okay, and please always make sure that the number of bonds there is 4. All right, so I've tried to do that as best as I can. Right, now notice, how do I name this? Now I want you to please note, if we didn't know better, we'd say, okay, look, we've got 5 carbons, 1, 2, 3, 4, 5. So what does that become? It becomes, the prefix is pent, sorry. So our prefix is going to be pent. But what is our suffix in this case? We know we've got a double bond there, so it's going to be pentene, right? So that's pentene. But look at this. If we're to look at this, 1, 2, 3, 4, 5, this would also be prefix pent, and we've got a double bond once again, we've got in. Now notice, ladies and gents, it would be the same name. It's almost like the name pentene would be ambiguous in this case, right? You've got one word meaning two things, okay? So what's different between these two structures? I'm sure you've already noticed. Can you see that this one has got the double bond between the first and the second carbon, right? What about this one? It's got the double bond between the second and the third carbon. So in this case, if you were to say to someone, okay, draw the the structure of pentene, okay, and someone else gave you that, and someone else gave you that. Remember, these are two different chemicals, right? So we need to be saying the same thing when it comes to language, or the language of organic chemistry all around the world. So when you ask for something, if you say pentene, we need to have a common understanding, all of us, right? In this case. So how do we rectify that problem? I'm sure you already see these are actually isomers of each other. All right, same molecular formula. Okay, so if you notice, molecular formula would be C5, okay, and then hydrogens, you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be H10. You can count these ones as well. You'd find the same thing. So you'd get C5 H10 as well. Okay. Right. We're going to talk about general formulas a little bit later. There's so much to learn on organic chemistry, that I'm going to actually break it down into different parts. Right, so in this case, how do I name this guy? So we said now we need to start introducing a numbering system, right? You always number from the side that is closest to your functional group, isn't it? What is our functional group this time? Our functional group in this case is going to be the double bond that exists between the two carbon atoms there, right? So where is it closest? Do I number left to right, or do I number right to left? Right, so in this case, I want you to note, because our double bond is closest from the left, I'm going to number from the left-hand side, okay? So this is 1, 2, 3, 4, and 5, right? Now follow me as I number, okay, as I name. So this now is going to be, and please, I want you to note, it's between carbon number 1 and carbon number 2, but when we name for double bond or triple bonds, what we do is that we take the smallest carbon, okay? So therefore, this will be between carbon number 1 and carbon number 2. Which one is the smaller number? It's 1, definitely. So this will become pent, okay? So we use pent 1, in. So this becomes pent, it's 5 carbons. And at carbon number 1, I've got a double bond, which is that in there. Okay, nothing wrong if you wanted to say 1 pentene. Okay, that is kind of an older naming system, but it still works nonetheless. Okay, so this is at carbon number 1. We've got a double bond there, so this is 1 pentene. And then how would I name this one? Okay, so where do I start numbering from? Left to right or right to left? So I'll say, okay, this is 1, 2. So it would be at carbon number 2 if I went to number from the left-hand side. 1, 2, 3. It would be at carbon number 3 if I numbered from the right-hand side. So we want to get the smallest combination of numbers. So we number from the side closest, right? So again, it's going to be left to right. So this is 1, 2, 3, 4, and 5. Now notice once again, so how would I name? It would be at carbon number 2, right? Between 2 and 3, which one is the smaller number? It's carbon number 2. So this would be pent 2 in. And these are actually isomers of each other, right? So now we are more specific, right? If I said draw the functional group, I mean the structural formula of pent 1 in, that's C5H10. So you know now it's going to be pent, that's 5 carbons, at carbon number 1 and 2, right? Between carbon number 1 and 2. Then in this case, I've got what? A double bond, which is that in, our suffix there. And then what about naming this guy? We said, well, it's 5 carbons. And at carbon number 2 and 3, remember you always show the smaller carbon, the smaller address, the closest address, right? In this case, so between carbon number 2 and 3, you've got a double bond there. Okay, right. Now, let's take something that looks a little bit different, okay, before we combine all our things together. Right. So let's say we take something like this. Okay, let me... Okay. Oh, and by the way, how would you show this as a... in condensed formula? So this would be CH2. Okay, sometimes they do show the bond, so this would be CH2 CH. Can you see that C with 1 carbon there? CH2 CH2, and then just to squeeze that in there, that's CH3. Okay, right. And then what about this guy here? So we'd say CH3. Okay, can you see 3 carbons and 3 hydrogens rather? CH. Okay, right. Even if they didn't show the double bond there, so this would be CH CH. Okay, that's CH2 CH3. Okay, right. I hope you can see that quite clearly, right? So this tells me, man, these carbons were supposed to have 2 carbons, if these are 2 hydrogens rather, because these are carbons that are in the middle. So it tells me that there should be something there, and that something is a double bond. Okay, right. Now let's name something else. Okay, yeah, let's put a triple bond there. Okay. Oh no, I'm violating my own rules now. Okay, so let's take that there. Right, sorry for putting that there. Okay, those don't exist. Okay, so how would I name something like that? Okay, please help me out, ladies and gents. I'm sure you've got it by now. So where do I start numbering from? Left to right or right to left? Okay, right. We said we number from the side that is closest, isn't it? Okay, so look at this. If I number from left to right, it's 1, 2, 3, 4. Right, I've got a triple bond there. But if I number right to left, 1, 2. So where am I going to start numbering from? Yes, you've got it right. So that's 1, 2, 3, 4, 5, and 6. Right. And by the way, the reason that we do this is because you can just easily just turn this around. Okay, so in case the examiner just writes this in a different way, just note you always number from the side closest to your functional group, right? So in this case, what do we want? What do we name this? Okay, going to say, well, at carbon number 2 and 3, the closest, then smallest number is 2 there. Okay, so how many carbons? 1, 2, 3, 4, 5, 6. What's our prefix? It's going to be hex. Okay, right. What's our it's hex 2. Between carbon number 2 and 3, we take the smaller number, ein. Okay, so this is hex 2 ein. Please, ladies and gents, I did say I'm going to violate some rules a little bit. I'm going to not draw those hydrogens there, just for the sake of time, right? So this is going to be hex 2 ein. All right, so that is how we are going to name. Okay, right. So I want us to take just a different combination. All right, I hope you are getting the gist of it. Okay, we did say this is a language. We are taking it slowly but surely, right? but at the end we will all arrive in Canaan. Okay, right. So right, let's take something that looks so that's CH3 there. Right. Okay. So there it is. We've got a double bond, and you also have a branch, a side chain, right? So how would I name something like this? Where do I start numbering from? Okay. So in this case, I'm going to simply number from the side. Now, what do I give priority to? I always give priority to my functional group. What is my functional group in this case? My functional group is my double bond, my triple bond. Of course, we're going to still add some more functional groups for alcohols, for ketones, for all the other organic compounds, right? So in this case, what is my functional group, right? So the functional group is the double bond between the carbon atoms. Can you see that? So where am I going to start numbering for this guy, right? I definitely need to give an address. So where do I start numbering from? I'm going to start numbering from the side that is closest to my double bond. Yes, oh, but what about that guy? Nah, remember, this one takes preference, right? This one takes priority. So we're going to say, okay, so this is carbon number 1. That's 2. That's 3, and that's 4. And by the way, just please note that when we talk about aliphatic compounds, because they are chain-like structures, they don't necessarily need to form a straight chain like that. Okay, you can have a chain that is bent. Okay, so we'll talk about those probably as we go along. Right. So if you look at this, how am I going to name that? I know, first of all, we start with our side chain, right? We start with our branch, isn't it? So we're going to say, okay, so at carbon number 3 in our parent chain, so there's our parent chain there. So at carbon number 3 in our parent chain, we've got a side chain which has 1 carbon. Okay, so I'm going to say, okay, so this is 3 at carbon number 3. I've got a side chain, a branch which has 1 carbon. We said the prefix is meth. Now please remember, when it's a side chain, it's an alkyl group. All right, so the suffix is methyl. Please note the difference between methine, okay, sorry, not methine, rather, ein for the functional group when you've got a triple bond, and yl, right? So yl simply tells us something is still coming up, okay, right? So every time you put yl, there should be something next to it, okay? So that's 3-methyl, that's 3-methyl, right? We've got a methyl group there. And then now we go to our parent chain. What happens at our parent chain? So in this case, we've got bute, okay, and it's bute, 4 carbons. But between carbon number 1 and carbon number 2, which number do we take? We said we take the smaller one. So this is going to be bute-1-ene. Okay, so that's 3-methyl bute-1-ene. Right. Okay, let's try out another one. Okay, so suppose okay, let's try something a little bit different. Okay, we did say we are just making sure we're making progress one step at a time, right? Okay, so suppose we've got something like this. Okay, and I've got a methyl group there. Say I've got another methyl group there. Okay, let's just in fact, you know what, let me just make this right. Let's do that. Okay, right. Now you want to say to me, okay, but how do I name something like this? Okay, so I've got more than one side chain. In fact, you know what, I should have actually phased it in a little bit before we go to that one. Okay, in fact, let's take it one step at a time. Okay, if you don't mind, let me just remove that for now. Okay, we'll go to that. Let's have the same type of side chain. All right, now look at this. I know probably they'll not give you more than 2, but okay, let's see. How are we going to name this? So in this case, because I don't have a double bond or a triple bond, so the thing that is going to now take preference is my my side chain, right? Take priority are going to be my side chains or my branches. Right, now look at this. In this case, this is going to be 1, 2, 3, okay, 4, 5. So it's going to be at 3 and 5, right? If I number from that side, it's going to be 1, 2, 3, 4. So in this case, I would actually prefer to number from the right because it's actually closer to my side chains, right? So I'm going to say this is 1, 2, 3, 4, 5, and 6. Okay, right. Now, how do I name that? Now, please, I want you to listen to me carefully, ladies and gents. When you've got one, or rather 2 or more of the same things, right? Now, we need to actually put in a different prefix. Now, notice, when I've got 1 of the same thing, there isn't a problem. I didn't introduce anything, right? But if you've got 2 or more of the same thing, we use the prefix die, right? I'm sure you've seen this before. Okay, those of you who've done life science, you talk about plants, dicotyledons. Okay, so di means 2, right? So 3, we use the prefix tri. Okay, and if we've got 4, we're going to limit it to 4. All right, we use tetra. Okay, so we use the prefix tetra, right? So in this case, what we want to do is to say when we see 1 or more of the same things, then we know that we must use the prefix di, right? So look at this. So we're saying, by the way, if you wanted to know, for 5, it's penta, that's taking on, in a way, the same system as our prefixes for the carbons, okay? So we're going to simply say this is at carbon number 1, at carbon number 2, we've got a meth. So first of all, let's identify our parent chain. Which one is our parent chain? And you must be very careful, right, to make sure that you really take the longest one. So a parent chain, that's 1, 2, 3, 4, 5, 6. It could be 1, 2, 3, 4, 5. Okay, that's 5 there. That's 1, 2, 3, 4, 5. That's still 5 there. Or I could have said that's 1, 2, 3, 4, 5, 6. You see, so it would be a bent chain there. And believe you me, it wouldn't change anything about the naming of it. Okay, so now let's just deal with it as is. So there it is. Okay, right. So we're going to simply say, right, so we know that we've got our side chains there. Can you see I've got side chain which has 1 carbon, a side chain which has 1 carbon, a side chain which has 1 carbon, right? Now, I've got 3 side chains that are exactly the same. So, which prefix? It's tri, right? Okay, so I'm going to say at carbon number 2, now please, I want you to note, when you've got 2 or more of the same things, how we name, you won't say 2-methyl, 4-methyl, 4-methyl, right? So in this case, all we simply do is to say 2, 4, right? Now note, I will repeat again, 4, because remember, what we want to show is that there are 3 things that are different. And where do we locate them? They are located carbon number 2. That are the same rather. They're located at carbon number 2, carbon number 4, as well as carbon number 4, right? So carbon number 2, at carbon number 4, we've got a side chain. At carbon number 4, we've got a side chain. Yes, even if it means that you repeat the same number, right? For as long as you've got something there. So that's 2, 4, 4. This is tri. Can you see? So that's tri-methyl. Okay, can you see that? I've got 3 methyls, right? and I know where to locate them at carbon number 2, carbon number 4, and carbon number 4, trimethyl, and then I go to my parent chain. It's all single bonds, carbon to carbon, so this is going to be trimethyl hexane. All right, I hope you get the gist of that, right? So that's 2,4,4 trimethyl hexane, right? So you can see that clearly there. Okay, if you wanted to write down in condensed formula, so that would be CH3, CH2, you'd have C, CH3, CH3, and by the way, I'll show you just something else there. CH2, CH2, CH3, and CH3. Okay, that's what it would look like in condensed formula, right? Right, so when you've got more than one of the same thing, okay, two or more of the same thing, remember, we use that prefix di, tri, or tetra, right? So in this case, let's see. All right, how would we now name something like this? Okay, right, I'm not going to be, okay. Yeah, let's take that. Okay, so how do I name that? Right, so I'm going to say, well, what's my longest chain? You can say that's 1, 2, 3, 4. Okay, 1, 2, 3, 4, 1, 2, 3, 4. It doesn't matter which one you took of those, just as long as the longest, in fact, the longest there just still remains 4, right? Just to show you something else, what would happen if I had something like this? Okay, if I were just to add another one there. Okay, right, look at this. Now, please don't be mistaken. You can say, well, my longest is 1, 2, 3, 4, but look at this. If you were to say 1, 2, 3, 4, 5, that would be longer than 4, isn't it? So it means your longest chain, your parent chain, in fact, let's do that. Right, so my longest chain in this case would be 5, right? So now, how do I number? Okay, so I'm going to say, well, first of all, I needed to identify my parent chain. So this one now becomes my parent chain. All right, can you see that? And what do I have? I've got 2 side chains. Can you see that? Right, my 2 side chains, it's going to be methyl, and I'm going to have methyl there, right? Remember we said aliphatic compounds, they're able to make chain-like structures, and chains are not necessarily linear all the time, right? So look at this. So how do I name this? It's going to be carbon number 1, 2, 3, 4, 5. Okay, let's see if I named from there 1, 2, 3, 4, right? So in this case, I would have at carbon number 2 and carbon number 3, if I number from that side. If I number from the bottom, it would be carbon number 3 and 4. So yes, I think you've guessed it by now. I'm going to number from that side. 1, 2, 3, 4, and 5. Okay, right. So in this case, I've got at carbon number 2 and at carbon number 3, I've got a side chain. They're exactly the same thing. So I'm going to say this is 2, 3, right? Di. Okay, as soon as I see 2 numbers like this, I know I should follow that with the di. As soon as I saw 3 numbers following each other, I know I need to follow with the tri, right? So 2, 3 di methyl. Okay, so methyl, that's 1 carbon there. And in this case, how many carbons in my parent chain? That's 5. So this becomes pentane. All right. Okay, I hope you are getting the gist of this. Okay, right, we're going to add obviously some more compounds, but I'm only going to do that in our next video, right? So now I just want us to master how, once you get this, ladies and gents, believe you me, it doesn't matter what I give to you, right? you'll still be able to do the same thing. Okay, right. Now, in fact, let me just go to another page. Now, we know what happens when I've got more than one of the same thing, right? Now, the question is, what if I've got different side chains? What if I've got side chains that are not the same? So, for instance, let's take something this simple. Say I've got a side chain. I've got a compound that looks like this, and in it, let's say there we are. We've got a side chain there. Okay. Right. Now, let's take something as simple. Well, I know to you it might not look that simple. Remember, I did say I'm not going to put in the hydrogens, right? Now, how do I name something like this? Okay, so first of all, we said we need to identify our parent chain, isn't it? So let's see which one is the longest chain. So I could have 1, 2, 3, 4, 5, right? I could have 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. It doesn't really matter. This one still remains the parent chain. Okay, so let me go for the simplest one. The fact of the matter is the longest chain structure that we have is 5, right? So now, do you notice that you've got different types of side chains? So look at this. I am going to have side chains. Okay, I'm going to have a side chain which has 1 carbon, but I also have another side chain which has 2 carbons. Can you see that? So I've got different types of side chains, right? So now how do I name this? Right, yes, you guessed it. I'm going to number. So where do I start numbering from? Okay, maybe we need to do something a little bit differently there. Okay, so where do I start numbering from? So if I number left to right, 1, 2, 3, so it's carbon number 3 and carbon number 4. But if I number right to left, it's going to be carbon number 1, 2, 3. So it's 2 and 3. So that's a smaller combination. It's closer to the side, right? So I'm going to say this is carbon number 1. This is 2, 3, 4, and 5. Okay? Right. So carbon number 1 to 5. And I'm going to say at carbon number 2, I've got a methyl. And at carbon number 3, I've got an ethyl. Remember when we've got 2 carbons, we said the prefix there is eth, right? So our prefix is eth. So now I've got an ethyl group and I've got a methyl group. Now, how do I name this? Ladies and gents, I want you to note that you always try to put your side chains in alphabetical order, okay? And by the way, even when we do halogens, right, we still are going to follow the same rules, right? Haloalkanes, that is, right? We still are going to follow the same principle that we always place our side chains or our halogens, right, in alphabetical order. So in this case, I'm going to say, so this is methyl and this is ethyl. Which letter of the alphabet comes first? So it's not the number that takes the preference, but it is the letter of the alphabet. Okay, so which letter of the alphabet takes preference, right? Which one comes first, rather? Okay, so obviously it will be the E comes before the M, right? Ethyl, methyl. So in this case, I'm going to start with my ethyl. So at carbon number 3, but you might be thinking to yourself, but now why didn't you start with a smaller number? Remember, we said what takes priority or what takes precedence in this case is the letter of the alphabet and not necessarily the number, right? So I'm starting with the E, so it's found at carbon number 3. So that's 3 ethyl, okay? And then I'm done with this one. At carbon number 2, notice a hyphen every time there's a letter and a number next to each other, right? That's 2 methyl, okay? See, E comes before the M, all right? And then what is the last part, carbon. I've got 5 carbons there, so this is going to be pen. Okay, I've got single bonds, so that is going to be pentane. So that's 3 ethyl, 2 methyl, pentane. Okay, right. I hope you're getting it, ladies and gents. Right, we did say it's a language. We are developing one step at a time. One step at a time. So let's take something else. Okay, say maybe we've got something that looks like this. Okay, right, okay, I did not violate any rules there, right? So carbon, right? So let's put our side chains there. Let's put our side chains there, and okay. In fact, you know what? Yeah, let's just add another carbon there. Okay, and let's add another carbon there. Okay, right. Okay, I hear someone asking for another one. Okay, let's try and be as complex as possible. Right, now let's try to name something as complex as that. So first of all, we need to identify which one is our parent chain, right? So which one are we going to name? Which one is going to be a parent chain? Now, please, I want you to note, your parent chain should always include your functional group, okay? So our functional group in this case is a double bond, right? Between the adjacent carbon atoms, right? So now how am I going to name that? So first of all, I need to identify which one is the longest chain. So I'm going to say this is 1, 2, 3, 4, 5, 6. Okay, so that's 6 going that way. 2, 3, 4, 5. No. Sorry, 1, 2, 3, 4, 5, 6. It's still 6 going that way. So it would be the same thing. So 1, 2, 3, 4, 5, 6. So it still would be 6 going that way. So it doesn't really matter. Let's take the simplest one. Okay, right? Nothing wrong if you had chosen that one or you chose this one. Okay, it would not affect the naming at all. Okay, right. So where do I start numbering from? I'm sure you've noticed by now we definitely need to number. So where do I start numbering from? Okay, so I'm going to start numbering. Okay, notice if I start from that side, 1, 2, 3. Okay, but remember what takes priority? We said the double bond takes priority. Okay, not the functional, not the side chains, not the substituents in this case, but rather the double bond, right? That's our functional group. So I'm going to number. The closest side from our double bond is the left hand side, isn't it? So I'm going to number from that side. So that's 1, 2, 3, 4, 5, and 6. Okay, so now I want you to please note, okay, so between carbon number 2 and carbon number 3, the smallest address is going to be 2. But what do we start with? I'm sure you got it by now. We start with our side chains, isn't it? Right? So now look at this. I've got methyl there. I've got a methyl there. And I've got an ethyl group. So which one are we going to start with? I'm sure you guessed it. Yes, we said letters of the alphabet, right? Comes first. So notice in this case, I'm going to say this is going to be at carbon number 4, right? I've got ethyl, okay? At carbon number 2 and at carbon number 4, I've got methyl. We said when we've got 2 of the same things, you remember that? 2 of the same things, what do I do? Right, so that's at carbon number 4, I've got an ethyl. At carbon number 2, at carbon number 4, I've got, remember 2, 4, that's dimethyl. Oops, I'm going to run out of space there. All right, sorry. Please, it's one word, right? But it's because I've just run out of space there. So 4 ethyl, that's 2, 4 dimethyl. Now, someone might want to say, ah, but D comes before an E. Now, please, I want you to note this one just designates the actual compound that we have there, substituent is the methyl, right? This one just tells us how many methyls we have. So that's 4-ethyl, 2,4 dimethyl, and then please, I want you to note, so that's going to be hex, right? So that's going to be hex. Now note, between carbon number 2 and 3, hex 2 in. We said we take the smaller number between the two. Okay, right. I think that was probably a little bit more challenging, right? I just want us to take the last two, and then what we're going to do is that I'm going to leave this video here, and then we're going to pick up from that in our next video. Okay, so I've got, okay, let's take just 2 more. Okay, so if I've got, okay, let's take something, right, let's put a double bond there. Okay, right, in fact, you know what happens when we've got more than okay, let's not violate the rules there. And that's 4, okay, yeah, that's fine. Okay, so let's put that there. Okay, see, I'm almost violating the rules again. Okay, let's put a, right, okay, right. So how do I name something like this? Okay, now if you can, ladies and gents, please, I want you to pause the video now and try to name this on your own, and then you can unpause it to see my solution afterwards. Okay, right, please, sorry about this. Okay, I've canceled them out. Right, pause it and then try to name it on your own. Okay, right. Okay, if you've just unpaused, right, let's name this together. So I'm going to have 1, 2, 3, 4, 5. Okay, that's my longest chain. 1, 2, 3, 4, 5. That's still the longest. In fact, that wouldn't qualify because it would make this one a side chain on top of another side chain. So I'm just going to take the straight chain one. Okay, so now once again, where do I start numbering from? You guessed it, right? So in this case, I've got a double bond that's closest to the right hand side. So I'm going to number from right to left. 1, 2, 3, 4, 5. I'm sure you got this by now, right? Okay, so I'm going to simply say, okay, between carbon number 1 and 2, I know I've got a double bond there, but where do we always start? We always start with our side chains, right? Okay, I've got an ethyl group there. I've got a methyl group. Which one comes first? Of course, okay, we're going to take the ethyl group first. So at carbon number 3, I've got an ethyl group there, right? At carbon number 4, I've got methyl, okay? And then, now notice, in this case, what do I have? Right, so 3-ethyl, E comes before the M. So 3-ethyl, 4-methyl, okay? Right, and then now we come to the parent chain. I've got 1, 2, 3, 4, 5. That's going to be, okay, pent. All right. Between carbon number 1 and carbon number 2, which one is the smaller number? It's 1. So that's pent 1 in. Okay. Right. Remember, that's the double bond there. So we take the in there, the suffix in, right? Okay, so the last thing that I want to cover. So what happens in this case when I've got more than one double bond, okay, or one triple bond? How would I name something like this? Okay, so once again, you're going to number from the side that is closest to your functional group. So notice this, your functional group, it's your double bond. So that's 1, 2, 3, 4. Okay, so so even if you named 1, 2, 3, 4, it's going to be at carbon number 1 and carbon number 3. But even from that side, 1, 2, 3, 4, so it would be at carbon number 1 and 3. So it wouldn't really matter in this case. 1, 2, 3, 4, right? So how many carbons do we have in our parent in our chain? So we have 4. So this becomes now bute. Now please note we've got 4 carbons. That's bute. Notice at 1, right? That's 1 and 2, right? So that's 1 and 2. So we take the smaller number. That's 1. And at 3 and 4, we take the smaller number 3. So that's 1, 3. At carbon number 1, at carbon number 3, we've got the same thing, right? Which is what? An ene, which is a double bond, right? So that's bute 1, 3 diene. Okay. Right, I've seen it numbered or named in this way. That's 1, 3. Okay, bute diene. Okay, right, so bute diene. All right, but I still would prefer this one. So that's bute, that's 4 carbons, that's 1 at carbon number 1. At carbon number 3, right, I've got a diene. Right, ladies and gents, I hope I've been able to somewhat scratch where it itches in terms of organic chemistry. So what we're going to do in our next video is that we are now going to be talking about the other organic compounds. So when we add, for instance, when we've got halogens, when we've got ketones, when we've got aldehydes and all the others, right? And I'll show you how the rules, what I've just taught you here, still remains the same, right? Okay, everything that you've learned still remains the same. Please, if you didn't understand, please just hold a comment, and please you can also reach out on email. So what we're going to do on the last video that we do, we're going to actually do some past exam questions, because what I want to do is just to consolidate by showing you that everything that we've learned, we can actually, we just want to make sure that we can apply it in an exam situation. Otherwise, thank you, ladies and gents. I hope that you'll enjoy organic chemistry. Quite a nice chapter, quite a nice section. Okay, if you do need to reach out to me, remember my email, mlungisi.m.nkosi@gmail.com. All right, and please just make sure that you subscribe if you haven't subscribed already. Okay, and thank you so much for watching. Until next time, sharp sharp.